Welcome to the Methane Pavilion. What a busy day we're having, and I'm so thrilled to be here with some esteemed colleagues to talk about the science of why we need to quickly reduce methane and other short-lived climate pollutants. Methane has emerged as the strongest lever that we can pull to quickly bend down the temperature curve and address the climate crisis. I'm here with Professor Tim Lenton of the University of Exeter, who has deep expertise on climate tipping points and feedbacks. I'm also here with Pam Pearson, who's the founder and director of the International Cryosphere Climate Initiative, and with Zaran Osho with the Institute for Governance and Sustainable Development, an international climate attorney currently on secondment to the International Solar Alliance. So thank you all so much for tuning in and for joining us today. We'll start with Professor Lenton, who is going to update us on the science of feedbacks and tipping points.
Thanks, Sarah. Thanks, everyone, for joining us. I often feel like one of the horsemen of the apocalypse telling everybody about the latest science on climate tipping points, but we have to tell it like it is as scientists, I guess. So to give you a little bit of a summary, we're at 1.1 or 1.2 degrees centigrade of global warming. We already see evidence of possibly having crossed a tipping point in West Antarctica for irreversible loss of part of that ice sheet and more than a meter of sea level rise. We see worrying evidence of accelerating change in other, what I call tipping elements of the climate system. So we see, of course, the fast and accelerating melt of ice in the Arctic that I'm sure Pam will talk more about. We have the accelerating melt of the Greenland ice sheet. We have the fresh water pouring into the North Atlantic Ocean from Greenland and from extra rainfall in the Arctic. And we can see that that's weakening the great overturning circulation of the Atlantic Ocean. When that happened in Earth's past, that drags the rainfall all around the tropics southwards. The band of rainfall disrupts the monsoons around the planet in West Africa, India, leaves heat behind in the Southern Ocean, another threat to those Antarctic ice sheets. In other words, we're seeing interacting tipping elements and the possibility of cascading tipping point risks even at low levels of warming. So what we've been doing as scientists is trying to summarize, okay, what's our best assessment now of what the list of these possible tipping points are and where are their temperature thresholds? And there's been some new work that's helped inform that. There have been many new model simulations, of course, but there have also been careful analysis of the observations of how the behavior of some systems like the Atlantic Ocean, the Greenland ice sheet, the Arctic sea ice, the Amazon rainforest, how are those systems fluctuating and responding to the perturbations they get all the time from the short-term variability of the weather? Basically, how quickly or slowly a system recovers from those nudges and perturbations is a measure of what we call its resilience. And if we see a system losing resilience systematically, that's telling us it could be heading towards a tipping point. And it's that signal of loss of resilience of these systems recovering more slowly from the hits they're getting that we pick up in Greenland, in the Arctic sea ice, in the Atlantic Ocean circulation, in the Amazon. So further support, I'm afraid, for clear destabilization of these bits of the climate system. And if we try to put our best estimates together of where the temperature thresholds are for different tipping points, we can line those up and we can compare them to what are current policies going to take us to 2.5, 2.7 degrees C of warming. Maybe compare them to if we believed current pledges were going to be met, where would they take us? Well, as of yesterday, maybe to 2 or just below 2 degrees C of warming. But I'm afraid if we wanted to really lower the likelihood of multiple tipping points, we really have to hold the line at 1.5 degrees C of warming. I mean, I can't show you the array of all these thresholds, but I can tell you for sure that even at 1.5 degrees C of warming, as you've heard, there's still a risk that you pass a significant tipping point in West Antarctica and possibly for the Greenland ice sheet. We can't rule that out. But those risks really ramp up in the 1.5 to 2 degrees of warming range, and then additional tipping points, you pass their potential temperature thresholds for a whole range of systems, abrupt thawing of permafrost. I could reel off a kind of increasingly terrifying list. Mm-hmm. So that, emphasizes something we all know already, that it really counts to limit warming to well below 2 degrees C and really to 1.5 degrees C. And so we've been trying to sort of take the climate projections of, different temperature trajectories, as they're called, into the future, and work out where you would cross particular tipping points on the different trajectories and where you would avoid them. And the problem is, on the current policy's trajectory, 2.5 or so degrees of warming, you cross through this century, 8 or 9 tipping points, and they come sooner as well, of course. If we really can limit the warming to 1.5 degrees C, we can avoid most, if not all of those. And if there's ones we can't avoid, we can at least delay them. Mm-hmm. And by delay, we're talking about the difference between, on current trajectory, we start crossing potential ice sheet tipping points in this decade and in the 2030s and certainly in the 2040s. Even if we can't avoid them on the lowest warming we can manage, we can delay them 20, 30 years. And that brings us round to the topic of the discussion today, which is what actions have we got at our disposal to slow down short-term, near-term warming. And the fundamental point is, if we can rapidly decrease methane emissions, that can really make a difference to rates of short-term warming. And it can also, we would phrase it as sort of shave the peak of warming if we're going to go on a trajectory where we exceed 1.5 degrees C for a while and then come back down. We can shave that peak down as well with tackling, methane and other short-lived warming agents. And I'm sure we'll discuss this in a bit more detail, but those short-lived warmers, and methane in particular that we're here to talk about, has, I'm afraid, particular potency in the Arctic as a warming agent, both directly itself and by the fact that the methane chemistry then affects what's called tropospheric ozone levels, and that noticeably means that methane and its ozone counterpart are really damaging in the high northern latitudes, particularly to those bits of the cryosphere. So that might be more than enough kind of mostly bad news from me, but hopefully we're here to discuss the real kind of critical importance of tackling methane emissions, because they can make a real difference on avoiding these tipping points in the short term.
Thank you so much, Tim, and thank you for grounding this conversation in the latest science, as hard to hear as it is. And thank you for all of your work in this field. Let's turn to Pam to hear thoughts, reactions, and paint us a picture too, please, of what's at stake in the Arctic.
Yeah, if Tim is sort of the first horseman of the apocalypse, I'm afraid I'm maybe going to be the second. And it's really appropriate that we're talking today about these issues. As we're sitting here, the IPCC is in plenary presenting the results of Working Group 1. And with ICCI, we work on actually all elements of the cryosphere, all the places that are ice and snow covered either seasonally or around the year. It's an honor to appear with these two esteemed colleagues. I always point out that 7 of the 9 tipping points in that groundbreaking paper are cryosphere related. And I just want to focus on a couple of these right now today. You're not going to hear me talking about Arctic sea ice all that much. The reason is that system has essentially already tipped. So it is not emphasized a lot in the summary for policymakers in AR6 because that system is already gone. We will not see summer sea ice for some period of the year around 1.7 degrees. We're getting quite close to that. But the reason that Arctic sea ice scientists say that that system has tipped is because the multi-year sea ice that was really the base of that system is already essentially gone. As it disappears further and further, we're going to lose that ecosystem. We lose the albedo effect, the world's refrigerator up there. That one's been lost. Now, it can come back as temperatures go down. It's probably the least essentially permanent threshold in the cryosphere system. But the warmer the ocean gets, the more fresh water we have pouring off of Greenland and Arctic glaciers, the harder it's going to be for that sea ice to come back and retake its role in the global climate system. So yes, 1.5, returning, I would say, as soon as possible to below 1 degree. Everything else I'm talking about is very based in paleo records in some ways, and you hear a lot about deep uncertainty from the IPCC. Well, the paleoclimatologists who work in cryosphere actually say that there's quite a bit of certainty. If we go back to the geologic record, we know how the Earth responds to higher temperatures. There's not actually a lot of uncertainty around that. There is some uncertainty, though, about the rate and how long we can be at higher temperatures before that tips. But if you like the Arctic, you'll love Antarctica. And that's really a huge influence on the global climate system. I would say the consensus among those who study the West Antarctic ice sheet, which is inherently unstable because it's not on land, it's over water. And so it can collapse fairly quickly, kind of like an ice shelf. It probably tipped a little bit below 1 degree. That's probably when we lost it. Now, the good news is that if we can stay below 1.5 degrees, that collapse of the West Antarctic ice sheet can be stretched out over a period of, a couple of thousand years even. You see with the projections, it's we're getting more and more sea level rise, 3 to 4 meters from West Antarctica, but it can take a couple of millennia. It's a lot easier to adapt to that than in the worst case scenario, where there's a lot of really good research that's coming out that's taking into account the way ice behaves, the way you get break off at the end of an ice sheet once it loses its ice shelves. The worst case scenario for Antarctica, when you also get the East Antarctic ice sheet engaged, once we are hitting 4 to 5 degrees by the end of this century, then a lot of the most sophisticated models say that the loss of the ice sheet could be much faster. And that in the IPCC report is this little dotted line that you see in the summary for policymakers. And that is called, a low probability, high impact. When the IPCC says low probability, they don't mean that it won't happen. That's a scientific term. That means that if these new models are correct, it's going to occur a lot faster. And then we're looking at 10 meters of sea level rise by 2300 just from Antarctica, and rates of sea level rise by the middle of the next century that approach 5 centimeters a year. Right now, we're at 4 millimeters a year. So it's just an exponential increase in terms of that loss. So that is and it's very irreversible because it takes a whole lot longer, like 10,000 years, to regrow an ice sheet than it does to lose it. The final element I wanted to talk about in the cryosphere system, there are others. There's permafrost. Also, there's polar ocean acidification, which occurs a lot more quickly. So these waters are already so acidic in the polar regions that we're seeing shell damage, and that's just at 420 ppm. But mountain regions, glaciers that we lose, we're losing a lot of the mid-latitude glaciers. If we can stay below 1.5 degrees, we can preserve a big portion of the Alps, of the Rockies, of the glaciers in New Zealand and Scandinavia. Once we hit 2 degrees, those glaciers are gone. And here again, it takes a much, much longer time to grow back a glacier than to lose it. It's a very steep curve, but we can sort of plane it out with very low emissions and preserve elements of these glaciers. And a lot of people talk about sea level rise, but for people living in mountain regions or affected by them, they provide really key water resources. Probably, the Peruvian Andes are among the most vulnerable to those loss of glaciers. But we also have Switzerland, for example, which relies on glaciers for power, for water resources for agriculture. And we're seeing this already in the American West, where snowpack is often not thought of, but snowpack and glaciers combined basically are giving water to most of the American West, and we're already seeing that so perturbed that I have to question whether or not as many humans as we have right now living in that part of the United States are going to be able to stay there. So, as Tim said, between 1.5 and 2 degrees is a huge difference in the global cryosphere. And one of the things we're trying to accomplish at COP26 is actually to have a cryosphere dialogue. We're hoping for a decision point so that this is a full day. We've had oceans dialogue, we've had lands dialogue. You would think that the SROC was the special report on oceans as opposed to the special report on oceans and cryosphere. And these areas are so important for ambition, for really emphasizing to the world's leaders that 2 degrees is just not a nice thing to do. It's too high when it comes to cryosphere. It really is 1.5. And the decreases in methane, and also I would say, and if we get a chance to talk a little bit later, in black carbon emissions have a huge potential in these regions because of the reflectivity of the ice and snow. And it also has lots of health benefits. That's something that we work in as well. So really, really happy that there's a methane pavilion, and really happy to be here.
Oh, Pam.
So now more about solutions.
Thank you.
Or you want to be the third horsewoman of the apocalypse?
I hope not. I hope
Indeed,
not.
she may. Pam,
Yeah.
thank you so much for your work to protect the cryosphere. And you and Professor Lenton have certainly made a strong case for scaling up ambition and faster action. Zarin, we haven't talked a whole lot about India yet. Can you chime in here on what impacts are already being felt and your perspectives on what we've heard on tipping points and feedbacks already?
Of course. Firstly, thank you so much for having me here. It's just great to share this stage with such wonderful panelists. Great question, Sara. India, I think it's not just about India, it's about the rest of the world. Pam here and Tim spoke about tipping points and feedbacks and what the Arctic and the loss of sea ice in the Antarctic, Arctic, the poles has to offer. I just want to add very quickly the element of the third pole, which is the Himalayan glacier range. The idea is a country like India, Pakistan, Bangladesh, the South Asian region more specifically, it's not intuitive. But these parts of the world, these countries of the world, which are closer to the equator, are directly linked to what happens in the Arctic and the Antarctic. So with the loss of the Arctic sea ice, what we are starting to see, and this is studies coming out of the Indian Arctic and Antarctic scientists, the National Center for Polar and Ocean Research, is confirming that we have a problem here, a significant problem. And the problem is that our monsoons, the patterns, the degree of the rainfall, that is going to shift. And if I were to put this problem in a more realistic context, may I please say 70%, almost 70% of my population, my country's population, which is 1.3 billion at this point, is dependent directly on the rainfall for agriculture. Having a shift in the monsoons means that India and other countries like us are looking at an internal security issue. And even though this is not intuitive, because India is not a country which is closer to the Arctic, we do not share we do not have territorial jurisdiction over the area, but we do have impacts, and those impacts are being felt now. And like Pam said, glaciers, water resources, the third pole, unfortunately, which is directly connected to what happens at the poles, the north and the south, we are starting to feel the changes in the glacial systems in the Himalayas. And if something were to go wrong at this rate, if there's no action taken, which will, we are looking at a situation of water insecurity. And not just for India, for the entire region. I was in the meetings yesterday, and I met with delegations from Micronesia, Palau. We are looking at people in island states, not just countries like India, which are massive, but also looking at the rights of indigenous people, the rights of people living in Pacific states that are going to be directly impacted by what happens with sea level rise. And the idea is of climate justice. What is the forum for people like us who are going to be the victims of what happens to come up and speak? So from that perspective, absolutely, I think Tim and Pam have very well sort of laid out the science here. The idea is the impact, the real life impacts on people. And particularly about India, we're starting to see the impacts now. State of Kerala in my country, every monsoon there is flooding. And God knows how many people lose their lives, their livelihoods. We had cloud bursts that is coming up. We have, a huge coastal line that is flooding at all monsoons. This year, our crops, the crop from agriculture for the winter crop, we had monsoons that went on until September, which has never happened.
Wow.
So just sort of to put, the science into real life perspective, these are the things that we're dealing with. And sure, there is customary international law, there are rights and duties, but the reality is the climate science will have to now lead what, rights and duties for the rest of the world looks like in light of what the impacts would be coming from tipping points and feedbacks. So I think that would be my 2 cents on this issue.
Thank you, Sara, and thank you for sharing your perspective with us.
Thank
That's
you.
very helpful. And Professor Lenton, I'm wondering if you can share with us what's next for you in the scientific community, and also if you can reflect on what draws you to events like this to actually speak out.
Well, good big questions.
The message you would have for other colleagues.
For what it's worth, folks, I found myself also trying to work on what are the positive tipping points in society, in our relationship with technology and with ecology, that we need to find and trigger if we're to have any hope of accelerating the change we need to decarbonize the economy as fast as we need to and get those greenhouse gas emissions down to zero. So I suppose that is taking the same kind of thinking, systems thinking, that allows us to identify the abrupt shifts, the feedbacks, the tipping points in the climate system, and recognizing that we have the same thing. We have feedbacks, we have sometimes very abrupt changes in social systems, and I'm trying to find and spot some real examples where we've seen positive tipping points. So coal burning has been shut out of power generation in the UK at least, and we know how that happened. Electric vehicles are the dominant, car that's bought in Norway now. And in food and land systems, we're working hard to find examples of positive tipping points and think through what will it take to scale those up? What coalition of actors do we need to scale things up? And I think that's quite apposite if we think about the opportunity stroke challenge with methane or with black carbon, with these short-lived climate pollutants, because as we've known for some time, we have methane emissions that tackling them would actually save us money as well as help save the climate. So it ought to be possible to get really strong, positive reinforcing dynamics going in that area, and it's almost a little crazy that it isn't already happening. So I suppose for me, it's this kind of lateral thinking, this kind of application of the systems thinking to the solutions that's kind of keeping me, allowing me to sleep at night and keeping me motivated, and the message I'm partly also trying to bring to a meeting like the COP.
Well, it's a timely message, certainly, with the launch of the Global Methane Pledge earlier this week, with more than 100 countries joining this commitment to rein in methane pollution 30% below 2020 levels by 2030, which, as I understand, is within the range of what's needed to keep a 1.5 degrees C future in reach, alongside, of course, aggressive work to reduce other non-CO2 pollutants and, of course, carbon dioxide as well. Zarin, I wonder if you could pop back in terms of this hopeful message and what policymakers should hear and what you'd like to see coming next now that this global pledge has been announced.
Of course. I think before I get into the solutions and the hopeful part of the discussions, I think we really need to understand what it is, what's this giant that we're dealing with. We're essentially talking about existential risks. Feedbacks that lead to tipping points, those are irreversible, that are beyond the control of humans. And we're essentially talking about the fat tail risk on the probability curve of climate risk. And when you get into the science, which Tim and Pam here will do a much better job than I can possibly do, we'll start understanding that what is at stake essentially is the future of the planet and the human race as we know it. We've already lost, I think, more than half of the reflective Arctic sea ice. We have lost about 17% of the Amazon forest. And I think those are also coming close to a tipping point. The idea is, what do we do now? And I think, Tim, I remember reading a quote from you. We have about 0 to 10 years left. That's no time. Mm-hmm. And we must emphasize that we're essentially looking at a calamity. And then you get into the real life impacts of it, which I think is just, it's horrible, and let's hope that doesn't happen. But essentially, what we're looking at is, give or take 10 years, 5 years, something like that. We need fast action now. And it's such a welcome change to see that world leaders are finally recognizing that. We heard the world leaders speak about stopping deforestation by 2030. And the fact that 2030 is the new 2050 is refreshing. What we need to do, in my opinion, in terms of solutions, is we first need to recognize why methane is important and why short-lived climate pollutants are important. The reason for that is that CO2 mitigation, absolutely, we must do it. The problem is CO2 does not cause cooling, because with CO2 mitigation comes cooling sulfates. So what do we have to do in order to make sure that we stop warming now, and also make sure that cooling as an impact comes out, is through SLCP mitigation. We've done HFCs under the Kigali Amendment, the hydrofluorocarbons. It's been the world's most successful environmental treaty. Of course, we need to act fast and do banks and include other things. But HFCs is a great example for the world to come together for a concerted effort and do something. The other thing I think is that is very important, which is to your point, Pam, about black carbon, especially in the poles, in the Arctic. We need to have a new agreement on what to do with black carbon. How is it that we can reduce warming from black carbon, particularly in the poles, and then hopefully stop the impacts of what lies ahead. The third thing, of course, is in the perspective of the global methane pledge. I remember when the methane pledge discussion started, it was about 8 or 9 countries back in September. And today, with the official launch, we are at more than 105. So clearly, there is acknowledgement and understanding that methane and other short-lived climate pollutants are a problem, and fast action on them is needed. I want to quote a number from the CCAC Global Methane Assessment Report, which says, the best case scenario would be 45% reduction, equivalent to 0.3 degrees of avoided warming by 2040s. That's a great number. That's a great aspirational number to have. What we must also understand is methane removal technologies. We are looking at, carbon removal. Why is it that we can't club methane along with CO2 removal technologies from the atmosphere? And moving along on those lines, I think at this point, with the launch of the pledge, which is huge, how do we make the pledge a real deal? We have, of course, the money, $300+ million to leverage. That is great, fantastic, from the philanthropies and other efforts. But at the same time, we're also looking at satellite monitoring. It may be IMEO, it may be the carbon mapper from California. These are real-term, initiatives that we, as a organization or as a group of experts, are taking in order to, understand what the real numbers are in real time and what should the policies be. I think the one last thing that I'm going to quickly sort of touch upon and open the discussions here to the larger group would be to emphasize the need that SLCPs, methane emissions mitigation, should and do belong in the heads of state leadership group. Mm-hmm. We are looking at the possibility of doing maximum mitigation at no or low cost, extremely cost effective. This is something world leaders can do. They have taken the initiative, so we must have a concerted effort to make sure that this continues. And how we make it a real possibility, I hope the Climate and Clean Air Coalition of the UN steps up, coordinates, makes this a real policy dialogue. where maybe we could, have a treaty in the near future or a agreement of sorts which replicates what the Montreal Protocol has done for the HFCs?
Well, we certainly have a broad ecosystem of organizations working on this issue and at the ready to really ramp up, especially now that this pledge has been launched, as you say, at the level of presidents and prime ministers, which creates valuable political space. We hopefully can all run through this door and capture the momentum, make that civil society social tipping point take place. Pam, I wondered if you wanted to expand on the black carbon component, anything else we should know there? Next steps.
And it's important, as there's this focus on methane, which is very, very clear scientifically. Part of the problem with black carbon, especially globally, is that black carbon is emitted with a lot of other things, and there are some situations where it might be cooling. That is not an issue when it's emitted in or near cryosphere, because it's so reflective underneath that we know that it's warming, especially once it deposits on ice and snow. And there are other pushers, like the WHO climate report that just came out, for example. Black carbon is particle pollution. And it is really, really important to people's health. It's been very strongly implicated in the COVID pandemic because it impacts the respiratory system. These are the very, very tiny particles. They can spread very, very far. And in terms of solutions, a lot of these are actually negative costs, similar to some of the methane solutions. One of the things we've been working on really worldwide right now, we've done demonstration projects with the CCAC in Peru, in India, in Punjab. We've done them in Russia and Ukraine, closer to the Arctic, is from open crop burning, where there is use of fire across the board in agroforestry, and I'm not just talking about, prescribed burns. This is 2 to 3 times a year in some agricultural ecosystems where farmers burn. And the key to that is actually working with the farmers with education, potentially subsidies, because the fires don't fertilize the soil, they damage the soil. They mean that farmers need to triple their use, in some cases, of fertilizers. It makes the soil more brittle. You get more runoff, you get more erosion, you get more wind erosion. If you use fire-free methods, then the soil is held more in place, it's more resilient to drought or to rainstorms, and again, they're making more money because they need to use less fertilizer. So that's why this is so negative cost. That's a real tipping point, to globally determine that there will be no more use of fire in agriculture, because we're not aware of a single crop where there's not a fire-free alternative. And these emissions become wildfires, right? Not the emissions, the fires can spread and become wildfires. And then you get even more black carbon, and you lose forests, you lose grasslands, you pump more carbon into the atmosphere.
A real
So
feedback.
this has a huge potential impact. It's something that we're really trying to work hard on. And added on to that with fires, we talk about black carbon, but we also talk about CO2. And we really can't lose track of that 8 ball, because CO2 stays so long in the atmosphere. That is why there is this 50% by 2030 that's needed. There are a lot of great pledges out there that might take us below 2 degrees. The problem is those are long-term pledges, and you can't get to net zero carbon in 2050 if you don't do 50% by 2030. So to have a realistic net zero, goal, that's why 2030 being the new 2050 is so important. You can't do 2050 if you don't do 2030. We've got 9 more years. And so it's really, really important. And we've got to walk and chew gum at the same time. We've got to decrease everything.
We must.
Yeah.
I'm hearing that there are multiple risks already here and ahead with a suite of tipping points, but also solutions that have multiple benefits.
And we can do this.
Are achievable.
Yeah, I mean, the IPCC in its special report on 1.5 degrees, it said, this transition is economically feasible, it's technologically, physically, environmentally. There are 2 missing elements. There's a wonderful figure in the facts of the SR 1.5. And the 2 things that are missing are societal, political, and cultural willingness to do so, and that's up to us.
Well, we're here to work on changing that. And when it comes to a source like agricultural burning or flaring, we can cut the CO2, methane, black carbon all at once. So that gives me hope. We are going to wrap up in about 5 minutes. Tim, what to add, and then what are your takeaways from today?
Well, I'm sat here sort of almost working in my head on thinking about scenarios for how can we get some positive tipping, some reinforcing feedbacks going in tackling these short-lived pollutants, so the methane emissions. You know, how can we accelerate that 30 by 30 transition goal and maybe make it by 50% by 2030, because that would be even better. And I mean, yeah, we know where the key methane emissions are coming from. One can imagine, you know, there could be a plausible scenario that where it's fugitive emissions from fossil fuel and natural gas sector, well, if we, on the one hand, we might choose to put more of a penalty price on letting those emissions out, but we certainly have the detection technology advancing incredibly fast to spot where they're happening and who's responsible. So I think given that those who are leaking methane out of their operations are losing money to the sky when they do it, it really ought to be possible to shut those down. It seems, okay, the livestock methane emissions sector challenge is a big one, but we talked about, we know that if we are going to keep eating, for example, beef, and we want to do it in an efficient way, we're going to see more and more of a shift to fodder feeding of cattle within sheds, at least in the mid-latitudes where I live. And that gives an opportunity, even if you haven't genetically engineered your cattle to fart less, to scrub methane at the cattle sheds, not let it out into the atmosphere, and people are working on that technology. I personally see the data that shows that there are upticks for change in diet away actually from the kinds of animal products that are associated with really high methane emissions. And I see incredible rates of technology change towards alternative protein substitutes for beef and other red meat in diet and in food products. I don't rule out that by 2030 there'll be really exponentially accelerating market penetration of those alternatives, and we won't know as consumers that the burger is actually coming from whatever it is, cultured bacteria, or I could tell you more, if we had the time. I won't take up all of the remaining 5 minutes.
Well, maybe another session on that.
But absolutely, there are all these signals that there are reinforcing feedback opportunities, and Pam was very eloquent on that when it comes down to the cook stoves, the benefits for respiratory health and the benefits for the monsoon and for the snowpack. We really shouldn't be surprising that we should see community-driven movements to get behind that and permeate those technologies and those alternatives.
Yeah.
Pam, what about you? What gives you hope moving forward?
Well, you can see one tipping point just here at the COP. By the way, I'm not a scientist. I'm a former diplomat. I hang around with scientists a lot, so I can talk like one. But at these climate conferences, has been a huge tipping point. If you talk to negotiators, how many of them are vegan, vegetarian, or almost vegetarian, to the point that there were complaints in Madrid because the non-meat meals ran out. And so they have made a huge effort here, the UK presidency, to just really up the amount of vegetarian meals, because that's what everybody's eating. So there's a tipping point right there of people who were aware of that. I think that the other tipping point that Tim referred to, we today, big focus on energy at the COP. There is the Beyond Coal movement that has just blossomed. Next week is going to be launched the Beyond Oil and Gas Coalition. We really need to get away from fossil fuels, period. There will be no fugitive emissions if we're not taking it out of the ground anymore. And so ultimately, that's where we need to go. And again, that's what the IPCC has said. So, and I also want to put a plug in then finally, something that's being used increasingly, and I think it's going to happen, is paddy rice methane. It's another difficult one, but there's alternate wet and dry methods that can really decrease the amount of methane emissions. So these solutions are out there, and we just need to ramp them up a lot more quickly than they would occur naturally, and that's the hope.
The need for speed.
Yeah.
The sprint we are in. And Zaran, over to you. What are your next steps? What gives you hope?
What gives me?
Hope.
Hope. Wow. I think the global methane pledge gives me hope. What Tim and Pam spoke about are usually bottom-top initiatives. I am somebody who thinks that top-bottom, in the case of methanes and SLCP mitigation, would be fantastic. And we're seeing the impacts of it through the Global Methane Pledge, 105 countries signing up and recognizing essentially what it is that is at stake and how is it that we move forward. I think what gives me hope is the fact that we have a movement here that we've built, and the momentum is being gained from all sides, be it the NGO, the think tank, the public, the private sector. Everybody's recognizing what needs to be done. And essentially that gives me hope. And what we're looking at is maybe in a few months starting to convert the pledge into real action points.
Absolutely.
And I think that is what is going to take it forward and move the needle slightly, which is any help is good help.
Well, outstanding. My takeaways today from our terrific panelists are that we have to keep a 1.5 degrees of warming as our limit to avoid or delay tipping points. Real impacts on people and the planet are here already, right now, and we need rapid action. And action on methane and other short-lived pollutants is an opportunity to make positive impacts, to shave the peak and lower warming even over the next decade. And finally, we need to take the momentum of the Global Methane Pledge and harness that and turn it into action on the ground. So I want to thank our audience today and thank our 3 terrific panelists. And I hope you'll stay around. We have another panel coming up at noon to dive more into the Global Methane Fund that was mentioned. And after that, we'll have a reception. So thank you all.